This is 8.1, part 2. This is a word problem. I would recommend that you write down the highlighted pieces that I have going to highlight for you. So the manager of a company assembles plant, knows that number of computers that workers can assemble varies directly as the time. So what I want you to write down is this. The number of computers that workers can assemble varies directly as the time. So write that down first. Then go ahead and write down the word given. And you're given 2 pieces. If the workers at the plant can take and assemble 1,260 computers, go ahead and write that down as given, 1,260 computers. And then the other given is 150 hours. We're going to ignore this last piece of this sentence. How long will it take them to assemble 1,890 computers? We'll save that for later. So the first thing we do in a word problem is we want to identify what the variables are. So step A, identify the variables. So there's 2 things we're talking about in this word problem. We're talking about the number of computers that a worker can assemble and the time it takes for them to do that. So identify your 2 variables, and how you know that is the direct variation equation. Notice this, I'm going to circle this word direct. It has to say y varies directly with x. So I go up and look to represent what is my y. So the statement here that I have underlined first is the number of computers. This is my y. So that's why I said the number of computers is my y. Then the second piece says the number of computers that the workers can assemble varies directly as the time. So this represents your x. So the time is your x value. Then part B is setting up that direct variation equation. So we have to go out and choose one of those 3 formulas. In this case, it's a direct variation, so y equals kx. Now remember when I said the givens? I had a given which were the number of computers. So y equals 1,260 computers. And then x equals the time. It takes 150 hours for this, the workers to assemble those 1,260 computers. So now think back to the last 3 examples. We're going to go ahead and substitute our givens in. So 1,260 goes in for y. 150 goes in for x. And we're going to first solve for that constant variation. So y was 1,260. Our k is our unknown. And then we have 150 hours. Now the next step, we solve for that k. So 1,260, let's rewrite in this equation, 150k We have to solve for k, so we have to undo that 150. The 150 is multiplying by k, so we have to divide both sides by 150. So 150 divided by 150 on both sides. The 150s will cancel, and then our k equals 8.4. Now we're going to go ahead and rewrite that equation with the k in it. So here's our general equation for direct variation. We're going to put the k in. All right. We're not done with this question. It's a word problem. It's wanting us to go out and predict something about the company. So I said ignore that second piece of the last sentence. So let's go back and look at that. So the last piece of this question says, how long, so that's our unknown, will it take for them to assemble 1,890 computers? Well, that's our y. So our last step is we're going to go out and find it. So what we substitute in is we substitute the x in or the y in. In this case, we substitute y in. So part E is to answer the question with k in it. So they gave us a new given, the number of computers were 1,890 computers, and we have to find out how long it takes, where x represents the time. So we're going to use that equation in the blue above and substitute in our given. So y equals 8.4x, we're going to substitute 1,890 in. Now we solve for x, which is our time. So we undo the 8.4. So we're going to divide both sides by 8.4. Now we get x equals 225. We have to put the units, hours. So there is our answer. There is one more style of variation equations, but I want to save that for our warm-up problem. It's called the combined one. So there's one other style. I'll go ahead and show you what the assignment is. Oh, we have to do these too, sorry. How can you tell you have a given set of ordered pairs if it is direct or inverse? Just go ahead and write these highlighted pieces down. If you have direct variation, then you have a constant ratio. So you take each y and divide it by x. If you have an inverse variation, then you have a constant product. So you would multiply x times y. It's getting to be about 9 minutes right now. I think I'm going to save the example of this for the warm-up, because it's about 20 minutes total for these two videos. The assignment looks like this for 8.1, page 573, 1 through 16.